We're doing what's called inverse trigonometric functions. Inverse is like when you undo things. So when I have sine of theta equals -1/2, what we're doing is we're finding the missing value. We're missing theta. That's our variable. So we have to find what theta equals. So we're solving an equation. Theta is always an angle, so all of these will be angle answers. So you look here and you say sine of the angle equals -1/2. And you guys right now should know a couple things. Should know sine of what is 1/2?
30.
30, right. We should know that sine of 30 is 1/2. We should also know where sine is positive and where sine is negative. So all, right, all, A, all, and then students take calculus. So this is all the trigonometric functions are positive. This is sine is positive. This tangent is positive, and this is cosine is positive. So when I look and I want negative sine, where is sine positive? Where is sine negative? Sine is positive in all, sine is positive in S. Where is sine negative? In the T and the C. That's where sine is negative. So we need two triangles. We need one that is in the third quadrant and one that is in the fourth quadrant. Remember, the triangles always connect to the x-axis. I'm drawing these because it's pretty helpful to have them drawn. I'm going to draw them for like every single one. If you can do it without the pictures, great. Most people need them. Okay, so you guys told me that sine is 1/2 at 30 degrees. So each of these are going to be a 30-degree reference angle. They're not an actual 30-degree angle, it's a 30-degree reference angle. We have to find the actual angle. So starting at our initial side and rotating around to our terminal side, what angle is 30 degrees past 180?
2 times.
Okay, the other angle, if I start at my terminal side, go all the way around, what angle is 30 degrees just less of the whole 360 degrees? What angle is 30 degrees just less of it? 360 minus 30, 330, right? So I have two answers. Theta could be 210 degrees or 360 degrees. 330 degrees, sorry. I'm just checking you're paying attention, that's all. Yes.
Can you move that more?
The entire
I
thing?
didn't get it right. Just from the arrows.
Right, so like to get to a 30-degree reference angle, that's not really 30 degrees. We're starting here and rotating all the way around. That's just like 30 degrees past 180. So it always connects to the x-axis, so I'm always going to compare it to either 180 or 360 or 0. I'm always going to compare it to either 180 or 0 or 360. Those are the numbers I'm going to use to find these values. Okay, let's do another example. By the way, the reason why I'm putting my answer in degrees and not in radians is because the directions tell me put your answer in degrees. You skip ahead in your notes, you'll notice, it might be on the, yeah, it's like the next two examples, it'll tell you to do it in radians. So we're going to practice both. Okay, so B says cotangent of theta is radical 3/3. Let's start with positive or negative. Let's start with that. So I'm going to draw my quadrant, and I'm going to say this is cotangent, which is the same as tangent. So when we think all students take calculus, where is tangent or cotangent a positive number? In all and in tangent. Those are the two quadrants I'm looking at. So we need an angle here and an angle here. They have to connect to the x-axis. The x-axis has to be one of their sides. The next thing we have to figure out is cotangent, square root of 3 over 3. What reference angle is that? Questions?
How do you know to just to put the triangles there?
Well, I know which quadrant because of the plus signs, right? Because it was negative, it would be in different quadrants.
So just like, did you do the same thing for that one where
Right,
positive?
they were negatives. Well,
Okay.
this one was negative, and like I knew which ones were positive, so it was the other two
Oh.
negative. So where this one's sine is y, and where is y negative? So, cotangent is x and y together, so where are x and y together positive? Either first quadrant or third quadrant where they're both negative and they make a positive. So I know where they're where they're positive. I also have to know the reference angle. Where is cotangent square root of 3 over 30? So there's the memorization part.
60.
It is a 60. It's 60. Tangent would be just radical 3 for this one.
Yeah.
Cotangent would be square root of 3 over 30. It's a 60 degrees. So my reference angle is 60. Okay, so now we have to actually figure out the real angles. Those reference angles are 60. What is the real angle? So we start at 0 and we rotate around how far to get to that one? 60 degrees. So if it's in the first quadrant, it's kind of easy. It has the same number as the reference angle. And then in the third quadrant, we're going to rotate around. I'm going to pass 180. I'm going to go 60 degrees past 180, so 180 plus 60 is 240. So I have two answers. Theta equals 60 degrees and 240 degrees. So you see we still need to know those values, and we need to understand where they're positive or negative. All right, let's do some more examples. Questions? So example 2, find the exact solution set of each equation if, now this time it says theta is going from 0 to 2 pi. So that tells you your answers have to be in radian form. So when we have our answer, instead of writing like 30 degrees, what would I write? Pi over 6. So you have to know your radians also. So the first one says 2 cosine theta equals radical 3. I can't solve this yet because there's an extra number on this side. So how can I get rid of the 2 and just have cosine theta? Yeah, we're just going to divide by 2, solving an equation. You guys have solved equations a few times in your life. Maybe. And we have cosine theta equals radical 3 over 2. So now you think, where is cosine positive? So cosine is the x.
A and C.
It's going to be A. All students take calculus. It's going to be A and cosine C. You can also think about it this way. Cosine is the x value. So which quadrant is x positive? In this quadrant and this quadrant. X is positive. Remember, your triangles have to connect to the x-axis, always. I had people drawing triangles wrong yesterday. A lot harder to get your answers that way. So here we have 2 reference angles. We've got to figure out what those are. When is cosine equal to square root of 3 over 2?
When cosine is 30 degrees.
30? 30? 30?
Yeah, 30.
30? What's the sine of 30?
Okay.
So then the cosine of 30 is the other one, radical 3 over 2.
Yeah.
So these are 30-degree reference angles. Okay, but it's not really 30 degree for our answer. Our answer needs to be in radian form. So 30 degrees as a radian is pi over 6. This one is in the first quadrant. That one is pi over 6. But the other one, we have to go all the way around, and we are just 30 degrees less than all the way around. So we are pi over 6 less than all the way around. That is 11 pi over 6. So we have 2 answers. Theta equals pi over 6 for 11 pi over 6. Yeah. Because it's, I was just saying that's where it is positive, so this is where it is. Oh, yeah. Does anybody have handy? I want you to like dig forever, I just want to hold it up. When we made that huge unit circle in like one of our first notes. Oh, by the way, if you know you have it, it might be helpful. Nope. It might be helpful to have it anyway. Yeah, then I pulled it up. What notes are those in so we don't remember? 9-3. Oh, that makes sense because that's what we're doing right now. 9-3. In your note packet from 9-3, we made this unit circle. And that might help you when you're doing the radian part to know that that is 11 pi over 6. It might help you to have that. But really the most, the more that you do without looking at this, the more you're going to remember it and be able to figure out the answers by yourself. But since we are just doing homework right now, there is something that could help you. Okay, next one. Great. Question B. We have to solve this equation. So we have to get cosecant by itself. What should we do first to solve this equation? We have to get cosecant by itself. No, you can't divide it. But you can subtract 3 cosecant from both sides. Subtract it. I'm going to subtract it. I'm going to get cosecant theta plus 1 equals 0. Still need to get cosecant theta by itself. So we're going to subtract 1. So cosecant theta equals -1. Okay, so cosecant is the reciprocal of sine. So if you don't have your cosecants memorized, maybe you have your sines memorized. So if I want to think about this being sine of theta, I would have to reciprocate -1. What's the reciprocal of -1? Just -1. So we need to know where sine is -1. So sine is the y. So that tells me it's somewhere down here. Because that's where y is negative. Where is y -1? There's only one place. You know. Oh, you're saying the answer? Yeah. There's only one place when sine or cosine are 1 or 0. It's usually a quadrantal angle. That's the one that's right here on the axis. That ordered pair right there is 0, -1. That's the only place where sine or the y value goes down to -1. Other than that, the y value is less to make that circle. That's not a circle. You guys remember when we graphed it, there's only one place that sine goes down to -1, and then it comes right back up after that. So this is the only place where sine could be -1, or cosecant could be -1. So it is 270 degrees, but we have to put our answer in radians. So what is 3 pi over 2? So did anybody think in here we're going to have 2 answers every single time? Because we did until this one. So sometimes we might just have 1 answer. You just have to know where that value occurs. Okay? All right, example 3. Find the exact solution set for each equation if 0 degrees less than equal to theta less than equal to 360 or less than 360 degrees. How are we going to write our answer for this one? In degrees. Yay. What do you think we need to do first to solve for sine squared theta? Add 2. So add 2, we get 4 sine squared theta equals 2. What should we do next? Solve an equation. Divide by 4. So I get sine squared theta equals a half. Does this say sine theta?
No.
It's not. It says sine squared theta. So we have to cancel out a square. How? Square root. But if we do a square root, you gotta do plus minus also. Okay, so when we do square root of 1/2, that is the same thing as the square root of 1 over the square root of 2. Are we allowed to leave a radical in the denominator? So how do we rationalize that? We multiply by square root of 2 over square root of 2. That gives me what on top? Square root of 2. That gives me what on the bottom? 2. So we have plus minus square root of 2 over 2. Is that something that sounds familiar?
Yeah.
So I'm going to think signs. Where is it positive or negative? In every quadrant. So we have how many triangles to draw? 4 of them. 1, 2, 3, and then 4. 4 different triangles to draw. And somebody already yelled out, when is the sine square root of 2 over 2? Reference angle 45 degrees. So my first answer is 45 degrees. Then the second one, you've got to start at our initial side and end over in the second quadrant. What degrees is that?
135.
135. Then the third one ends in the third quadrant, so it'd be 180 plus 45. 225. And then the last one goes all the way around, but you can think about it as 360 subtract 45, 315. So again, if you don't have all that stuff memorized, it should already be on this unit circle. All those 45s should be on here. But it is more helpful if you can do it without the unit circle. All right, B. Oh, so we had 4 answers for that one. So B is 2 sine theta cosine theta minus sine theta equals 0. Does that look fun?
Not for real.
Okay, so there's this thing that we've been doing since, gosh, what chapter did we start? I don't know, chapter 3 maybe, called factoring.
Oh my
It
god.
allows you to solve a lot of things. So we are going to utilize factoring. And what's our very first step of factoring? Is there a GCF? The terms are separated by the minus sign, so here's one term and here's the other term. There is a GCF. There's a sine of theta in each term. So let's undistribute that sine of theta. Remember, when you undistribute it, you divide it out. So what's left over when we divide out our sine of theta? 2 cosine theta minus 1. Question?
Isn't there 2 sides? Isn't there 2 sides?
So I'm dividing out the sine, and then what's left? 2 cosine. And then I divide out the sine, and what's left? 1. Any questions?
I thought the 2 would have been with the sine of theta. And meaning these 2 then. So
Okay,
it would have been.
right, so it's not really 2 sines, it's 2 of whatever it's next to. So it's 2 of that whole thing. But when we do multiplication, I know this is super confusing, but when you multiply numbers, can you multiply them in a different order?
Yeah.
So that 2 could be with anything,
Okay.
okay? It's a little easier to see with numbers than that, but yeah. Okay, so when we are solving by factoring, after we factor it, how do we solve by factoring? Set each factor equal to 0. So it should already say equal 0 if you're solving by factoring, which I've set up for you. We're to set each factor equal to 0. Set each factor equal to 0. We're going to solve each factor. So I'm going to look at the first one, sine theta equals 0. That one's already kind of solved. I just have to find the angles. I'll go back and do that. Over here, we still have to solve this one. So what are we going to do to both sides? Add 1. So we have 2 cosine theta equals 1. And then we're going to divide by 2. So cosine theta equals a half. And then we're going to find our angles. So where is the sine of theta equal to 0? Now the sine of theta is y. So we're thinking, where is y? Ordered pair, where is y 0? Where is y 0? On the x-axis,
Yeah.
here and here. Those ordered pairs are 1, 0, or 0, or just kidding, negative 1, 0. There we go. So this one is at what degree? Okay, so it is 0 or 360 or 720 or negative 360 or negative 720 degrees. Like there's so many choices of what that could be. So in the directions, am I using 0 or am I using 360? Look at the directions.
0.
Right. The directions say,
Equal to 0.
right, it can be equal to 0 but not equal to 360. So it's limiting you just from 0 but not 360. So this will be a 0 degrees. And then this one over here is 180 degrees. Whoops. Elbow. It always happens in this shirt. Okay. And we got to solve this one over here. Cosine is equal to a half.
60.
That is a 60-degree reference.
Yeah.
But where is it positive?
On the left sides.
Cosine is positive in the first quadrant and the fourth quadrant. That would be the right, yeah. The other left. That's all right, I do that all the time.
I do that when I drive.
Yeah, I do
I'm
too.
like,
Oh, I don't do that while I drive, but.
Oh, I've done it. People are like, take a left, and I'm like, and that way.
I more like say to my husband, take a left, and then I get mad at him. Because he goes the wrong way.
other.
Oops, sorry. All right, so cosine is a half at 60 degrees, and we've got 2 quadrants here and here. This is a 60-degree reference angle. So this one is 60 degrees. But for a 60-degree reference angle here, we're going all the way around the other side.
300.
That'll be 300 degrees. So let's write our answers for this problem. Theta equals 0, 60, 180, and 300. One more example? Mm-hmm. Okay? So when you see a cosine square, that's telling you that we're going to have 2 parts to solve,
Oh man.
right? Just like the last one didn't have a cosine square, it had a cosine and a sine next to each other. but it's going to tell you about 2 parts to solve, and it might mean factoring. So we're going to look at factoring for this one, and we have 3 terms. I'm going to take this and I'm going to rewrite it in something that makes more sense to you when I talk about factoring. A little bit easier to see. If I'm going to take this, I'm going to write this as 2x squared instead of just 2 cosine squared minus 3x plus 1. Could you factor that one?
Yeah.
Okay, how would we factor this?
Yes, and check.
This one check. This one would be 2x and x. This last sign is a positive that says both signs are the same. The last number is a 1, which can only get from 1 times 1. Both signs have to be the same, but add up to be negative, so they've both got to be negative. We check it. 2x times minus 1 is minus 2x. Negative 1 times x is negative 1x. Yep, that adds up to be negative 3x. So we factored it. Except for it's not an x. Cosine. So it's really 2 cosine theta minus 1 and cosine theta minus 1. You do not have to do the x step. You do not have to do the stuff in blue, but I know some of you, to look at all those letters, it gets confusing, and if you just had one letter, it's a lot easier to factor. You're more than welcome to do the part in blue. You do not have to do the part in blue. But you have to end up in the factor form. Yes?
What about the squared?
Oh, no. Which square? Help me out.
The cosine squared, or the 2 cosine squared.
So there's 2 cosine
Okay.
times cosine, so that would multiply back
okay.
together to give us cosine squared. So this is factored, and we should only have 1 power for each of those factors. Okay, so then once it's factored, we're going to set each factor equal to 0. 2 cosine theta minus 1 equals 0, and cosine theta minus 1 equals 0. And we're going to solve each of those factors. So 2 cosine theta equals 1, so cosine theta equals a half. Oops, I just totally wrote it. And on the other side, cosine theta equals. Okay, then we gotta draw some pictures and figure out where these are. So I'll start with cosine theta equals a half. That's positive. Where is cosine positive? Cosine is the x. Where are x's positive? To the right. Positive and positive. That's where all of them are positive, and that's where cosine are positive. And did we just do this one? But did we just do this one?
Yep.
Did we just find cosine and a half? So that is a what? 60. And then this one's reference of 60, but what is it actually? 300. For that one, cosine equals 1. You need to know where x is equal to 1. It's got to be somewhere over here. Where is x equal to 1?
On the axis.
On the x-axis. And am I going to do 0 degrees and 360 degrees? No. I'm just doing the one that it said that it includes in the directions, which is 0 degrees. So we've got theta equals 0, 60, and 300. Okay, so what's really helpful to doing this assignment? Knowing those values. You've got to know those values. It is a requirement. You've got to learn them. I'm going to pass out this worksheet. You guys have some time to work on it. We'll take a brain break. Well, let me just get everything passed out.
How are we doing those two?